Hello friends, this morning I would like to talk to you about some special matrices that we have. Of course, there are so many of them. I've just chosen two. The first one is what is known as a singular matrix. A singular matrix is a matrix that is without an inverse. It does not have an inverse. And why doesn't it have an inverse? It's because its determinant is always equal to 0. So when the determinant is 0, then it means a matrix has no inverse, and therefore it's known as a singular matrix. And so you have to keep that in mind. The second one is the identity matrix. So this is a matrix that we get when we multiply a matrix by its inverse. So you multiply a matrix by its inverse, and you end up with what we call an identity matrix. And this here is an example of an identity matrix. It always ends up with ones and zeros. In one diagonal there are ones, and in the other one there are zeros. Okay, so an identity matrix has a determinant that is equal to 1. So now let's look at some calculations that involve determinants. Okay, so we are now going to look at some calculations that involve determinants, and here is a question that we are going to use to help us. Okay, so let me just put this paper here so that we see what we can do about it. So given that b is equal to 2x, 4, 5, and 2, find x if b is singular. Okay, so we start from there. So the first question says find x if b is singular. So A, we are saying b, which is this matrix, 2x, 4, 5, and 2. So the question tells us to say that if this is a singular matrix, we should find the value of x. And so what we are going to do here, we know that a singular matrix has a determinant that is equal to 0. So we are going to calculate the determinant for this matrix. Determinant of b is equal to 2x times 2 minus 4 times 5. 4 times 5. Okay, so here we are going to simplify. 2x times 2 is 4x minus 4 times 5 is 20. Okay, so since the question says that the matrix is singular, then we know that the determinant is 0. So we are going to replace the determinant with a 0 there. And then we can collect the like terms now. So negative 20 will come this side to be a positive number. So we are going to have 20 is equal to 4x. It has a negative, so it will be a positive when it crosses the equal sign. And then now we divide both sides by this 4 here so that we can have x remaining there. So we have over 4 and over 4. And so here, when these two cancel, you remain with x is equal to 4 into 20, you have 5 there. So when the determinant is 0 or the matrix is singular, then x is going to be equal to 5. Okay, so if there are any follow-up questions, for example, find the inverse and find anything, all you do is just substitute this 0 where there is x there so that you have numbers only, and then you can calculate the other things asked. So now let's go to part B of the question. So part B of the question says find x if the determinant of b is equal to the determinant of a, and a has been given here. Okay, so we have two matrices here. The determinant of b, let me write it here. Determinant of b was given by this formula here. So 2x times 2, we got 4x minus 20. So here it is. So we are told to say that if this determinant is equal to the determinant of this matrix, we should now calculate the value of x. So now we have to find the determinant of the matrix A. So the determinant of A is equal to, so our A is here, negative 4 times 6. So negative 4 times 6 minus 5 times negative 3. So this is going to give us negative 24, and then this negative times that one will give us a plus 15. And so here we are going to have negative 24 plus 15, which will give us negative 9. Okay, so the determinant of A is negative 9. So what we are going to do now is, since the determinants have to be equal, according to the question, we are going to get this expression for the determinant of b, which is 4x minus 20, and this should be equal to negative 29. Not negative 29, the negative 9 that we got here. Okay, so at this stage now, we are going to correct like terms. So we'll correct like terms here. We are going to have 4x is equal to negative 9 plus 20 when the 20 crosses the equal sign. So which will give us 4x is equal to negative 9 plus 20 is just 11. So we are going to have 11 here, and then we can divide by 4 both sides. And so our x is going to be 11 over 4 when the two determinants are equal. So let's go to the third question, which is part C of the question, so that we see how we can find x if the determinant of A is 36. Okay, so if the determinant of A is 36, how can we find x? So, or not the determinant of A, sorry, the determinant of B, because B is the one that has x. Okay, so we are going to find an expression here. This is part C of the question. We are going to find an expression for the determinant of B. So the determinant of B will be equal to 2x times 2 minus 4 times 5. Okay, so this is going to give us 4x minus 4 times 5, which is 20. So we have this expression now for the determinant of B, and we are told that the determinant of B is 36. So we are going to have now 4x minus 20 is equal to 36. And then we'll correct like terms. So 4x is equal to 36 plus 20. And so 4x will be equal to 36 plus 20 is 56. And then for us to find the value of x, we divide both sides by 4. So we're going to have over 4 over 4. So which will give us x is equal to 16. So x will be 16 when the determinant of B is 36. So this marks the end of our lesson. Thank you for paying attention.